Hi, we are going to convert molal to molarity, the concentrations. This is coming from the Jee test of August 26, 2021. It was the 9 a.m. test and it's question number 13. Let's look at the question. It says calculate the molarity of a 3.3 molal solution of potassium chloride whose density is 1.28 grams per mil. So I'm first going to write down just the units of concentration so we can see where we are and where we want to go. I do that often. Here's where we are, molal, which is moles of solute divided by kilogram of solvent. Molarity is moles of solute divided by liters of solution. Now let's unpack those words really quick as a reminder. The solution is going to be the solvent plus the solute. The solvent in this case is the potassium chloride. That's what's being dissolved. The solute is what does the dissolving, and in this case, it's inferred that it's going to be water. Always assume it's water unless you're told otherwise. So, given this 3.3 molal, let's go ahead and put in the specific units. The way you unpack this 3.3 molal, that is 3.3 moles of potassium chloride divided by 1 kilogram of water, and that's by definition. Having 3.3 is understood that that's divided by 1, and that molal tells us moles per kilogram. So that's how we can interpret that. You have to unpack that. Now looking at what we want, I eventually want to get over here to molarity, and I know that molarity has the word solution in it. So just a reminder, the solution is going to be the water plus the potassium chloride. So here's my molarity, what we have so far. Well, we know the moles, right there, look at that. I've got moles of potassium chloride, so I can go ahead and plug in the moles of potassium chloride. Remember molarity, mole of solute, we know how many moles we have. We've got 3.3 moles. Now divided by liters of solution, that's what we have to find. We've got to find liters of solution so we can eventually plug this in. So hold on to that for just a minute. Let me show you how to find the liters of solution. It's going to be down here. Okay, so again, liters of solution, that's going to be the water and the KCl. Well, they gave us the density. They gave us the density is 1.28 grams per mil. Well, if I know kilograms of water, let's just find the grams of the KCl. We'll add the grams together and then use density to find the milliliters, to find the volume. So I'm going to take my 3.3 moles of potassium chloride and we're going to convert that to grams. There's the mass of the KCl. Now the mass of the water, this is by definition when it said molal, that we had 1 kilogram. So I've got 1 kilogram of water, 3.3 moles were dissolved in 1 kilogram of water, that's the ratio. 1 kilogram of water, 1 kilogram has 1,000 grams, so that gives us 1,000 grams of water. Let's just add them together, and that will give us the grams of the solution. So 1,000 grams of water plus our 246.015 grams of KCl. Notice on this, I carried out the numbers, and at the very end, we'll truncate. So add this together, 1,246.015 grams of solution. I've got the grams of the entire solution, so here's where we use density. Let me write this down. This is the density. So there's 1.28 grams of solution for every 1 mil of solution. That brings us to mils, and then I want to bring it to liters. That's what I need for molarity, and so it will be 1,000 mils, or in 1 liter, that gives us 0.97345 liters of solution. So nearly a liter of solution. So let's go ahead and fill this out. I've got my moles, 3.3 moles of KCl divided by the solution, which is 0.97345 liters, and that's going to give us 3.39. Round that to 2 sig figs because they give us 2 sig figs in the stem. That's going to be our smallest number of sig figs. So you've got the 3.3 molar, and that's your final answer. Let's see, on the particular test, the answer for number 13, I want to tell you which letter it was. It was number 2. It was number 2. Let me write that down. So answer number 2. If you would like some further videos on discussions for molal or molarity, I will put some links up above and you can watch those. Thank you so much. Good luck on your test.